Hi there. I wanted to do a video on showing this problem. This was from the last quiz that you guys took, and I just wanted to go over it. So we did absolute value integrals when we were doing displacement and distance. If you remember, if you have a function where the function is the velocity function, v of t, then the displacement was the integral from a to b of v of t dt. Right, this is on a closed interval AB. And so that was a displacement, and so you just get f of b minus f of a. You just integrate the velocity function and you get the displacement. The distance, when we did the distance travel, then this is the integral, still on the same interval, but then you have to do the absolute value of v of t dt. So we practiced doing absolute value integrals when we did distance. And so remember, we had that if you had any function that happened to go under the axis, then you had to, for the displacement, you just do the integral from a to b. And so you will do this area, and this will be a negative area. So this kind of offsets, versus the distance, you have to take the absolute value. So for the distance, you will have to bring this up, and so you would add that area. So for this function, even though it's not asking about a distance, it is the absolute value, so you got to think about sine x. When is it above the x-axis and when is it below the x-axis? And so usually a graph helps, and if you look at the feedback that I gave in your quizzes, I said draw a graph of sine x and then do it from there. So notice sine x goes as high as 1, as low as -1, and it crosses at pi, and it's 1, its highest point is at pi over 2, and -1, its lowest point is at 3 pi over 2. And then you have 2 pi over here. So this integral is asking us to find the area between the function and the x-axis between 0 and 3 pi over 2. So notice that between 0 and pi is above the axis. But then you hit 0, and then the rest of the area that we want is below the axis. Because we want the absolute value, that means we got to bring this, mirror this image up. Oops. And so I want this area for the absolute value. And so that means that the integral from 0 to 3 pi over 2 of the absolute value sine x dx is really equal to the integral from 0 to pi of sine x dx, because this is already above the axis, and when it's negative, we have to reverse it, right? So then here, this will be y equals negative sine x. So plus the integral from pi to 3 pi over 2 of negative sine x dx. Right, whenever you want to bring it up, you just do negative of that function. So here, right, for this portion of f of x, then this portion up here will be negative f of x. And then we integrate. So the integral of positive sine is negative cosine from 0 to pi, plus this is already a negative sign, so the integral of negative sine is cosine from pi to 3 pi over 2. And then you evaluate. So cosine of pi is -1 minus cosine of 0 is 1 plus cosine of 3 pi over 2, which is 0, minus cosine of pi, which is -1. And so when you calculate this out, you have negative and -1, so that's +1 minus, oops, that should be a minus, right? So that should be a plus, because you have minus from f of b minus f of a, and f of a happens to be a negative cosine of 0. Cosine of 0 is 1. So I get plus 1 there, plus negative and negative 1, plus another 1. So the area would actually be 3. So I hope that that helps with this particular problem from the quiz and how to do absolute value. And remember, we did this when we did displacement and distance versus distance, which there was one on the exam that was an extra credit. And so a lot of you for the distance gave me the displacement actually. And so just remember that the distance is the absolute value of your velocity function. All right, hope that helped.